So the topic I'm going to be speaking today is democratization of artificial intelligence through cloud computing. Essentially, what I will be focusing upon is how cloud computing has enabled much wider adoption of artificial intelligence over the last 10 to 15 years. We all know artificial intelligence has been around since 1950s, but it was never widely adopted across the industry. Here's a brief outline of the overall presentation. We'll talk about the fundamentals of artificial intelligence. We'll talk about traditional challenges for widespread adoption of artificial intelligence, compute and storage, need for deep domain expertise. These are the things which basically prevented people from adopting artificial intelligence on a wide scale. We'll talk about how cloud computing has changed the game, how compute and storage has been affected in terms of easy access to them by, common masses, how software as a service, platform as a service, and off-the-shelf solutions have actually helped adoption of artificial intelligence. And we will talk about the path forward. What I would be doing is, as I go through the presentation, I don't want this to be a monologue going from one side. So once I present topics, I may stop sharing for 30 seconds or a minute and let people ask me questions. So with that, here is a high level overview. A lot of people worry or think about how is statistics related to deep learning or machine learning. Well, statistics is where the whole thing started in terms of mean, median, standard deviation, and then correlation and regression in terms of linear and logistic regressions. Over a period of time, then machine learning came up, which had things like pattern recognition and genetic algorithms. And then deep learning is essentially nothing but an advanced version of what used to be called the neural networks. So that's the overall, flow of how the history has developed. This is how I look at the overall field. Artificial intelligence is the broadest bucket, which has got program that can sense, reason, act, adapt like a human being. Machine learning is something where performance improves as they're exposed to more data over time. It's like a subset of artificial intelligence. And deep learning is actually even a smaller subset of machine learning, where we basically focus upon, leveraging different kind of highly dense networks to figure out how exactly we can implement neural networks much more efficiently. That's the way these two different domains fit in. It's okay if you do not understand everything right now. We are going to be talking and getting to the next slide, which is going to give you an idea of what artificial intelligence model basics are. And the way I look at it is, we develop a model based upon historical data and inputs, and these models basically have an output, based upon the kind of data that has been fed into. And then over a period of time, the output is used to improve the model through what is called a feedback loop. I'm going to, stop here for a second. Let everybody grasp this concept, which is a very important concept in artificial intelligence in terms of what is called continuous training the model using historical data, doing an inference, and then having a feedback loop for continuous improvement. That's the way I look at it. So, I'm going to stop sharing for a second and see if anybody has any questions at this stage for the next 30 seconds. Thank you. Good. So let me go back to sharing my screen and moving forward with my presentation. I will have give chance to people at the end to ask questions as well. So the key traditional challenge for widespread adoption of artificial intelligence was compute and storage, right? We had a high need for compute and storage resources for AI applications. These are very compute and storage intensive programs and processes. It was good and it was important, but everybody could not afford it, right? It's, compute and storage was not available on a mass scale at a low cost. And so as a result of which, we did not, and we also did not have a way to basically rent out compute storage. It was getting into artificial intelligence meant that you got to have high capex requirements. I remember working in artificial intelligence as a graduate student, at University of Cincinnati between 1997 and 1999. And we used to have this big Sun Ultra Spark workstations, which we used to use for, running AI ML algorithms. And it was not something that every startup or every company out there can basically figure it out or use it. So it was something that we all knew and we needed it. So with NVIDIA, Intel, Network Appliance, Dell EMC, some of these big players used to build this massive systems. Storage side was Network Appliance and Dell EMC. On compute side, it was NVIDIA and Intel with GPUs and CPUs. These were the key challenges. And then to basically work in the area of artificial intelligence and develop solutions, we needed a deep amount of expertise as well in natural language processing, computer vision. We needed specialized domain expertise. We did not have platforms for managing model development cycle. We did not have off-the-shelf industry solutions. So you basically needed to do everything from scratch, build models, deploy them, needed expertise in different areas of artificial intelligence to basically build the systems which can take us to the next level. What happened was, and so these are the key challenges from the compute and storage perspective, key challenge from the domain expertise perspective. Before again I move forward to the next one, I would like to give 30 seconds to the people to see if they want to, specifically ask any questions that they're interested in. So moving on to the next topic. The advent of cloud computing, things changed. The three big cloud players that you all are aware about, Amazon Web Services, Google Cloud, and Microsoft Azure, they made it very easily, storage and compute very easily available. And this became an OpEx model from a CapEx model, which basically means that we essentially can run, basically rent out compute and storage on this cloud and basically run them with us. And that changed the dynamics. So people typically think about these cloud players as having brought about a change in the cloud computing paradigm. They're having a big influence in artificial intelligence and machine learning as well. Because the key challenge we talked about in terms of compute and storage not being available is much easily available. And I'm trying to simplify the overall paradigm so that you understand, what exactly is going on. And similarly, these companies essentially provided a lot of ready-made solutions which are available through the cloud, software as a service, platform as a service, as well as industry-specific solutions. So, Amazon Comprehend, Amazon Recognition, the software as a service solution, which you can directly use. Recognition is a video analytics kind of a platform. Platform as a service was Amazon SageMaker, which is MLOps service, or TensorFlow, which is basically a model, a platform for building AI ML models. And then industry-specific solutions, which have Amazon Personalize, Amazon Fraud Detection, which are for specific applications in the industry, whether it's recommendation system or figuring out fraud, different kind of things. So I want you guys to again spend a minute or two, or maybe at least a minute, looking at this and getting this concept very clearly grasped. That way you can correlate cloud computing and artificial intelligence together and bring them. Um, any specific questions that people may have? Happy to answer them as we move along. Okay. The question is, what is the path forward? How this industry is going to develop? So the way it's going to be there is, we'll have multiple different kind of cloud paradigms being adopted and used. Hybrid cloud, which would have cost, data gravity, and data security. We'll have public cloud, which has dev and test workloads. We'll have private cloud, where the actual production workloads will run. And then we'll also be using public cloud for temporary busting, which means that, there'll be some public cloud, there's some private cloud. You'll run your, jobs Basically, if you want to do development and testing, you'll do it on some public cloud, the production workloads, which are in private cloud. And then if there's a high bursting, you go to public cloud. That's how the overall industry paradigm will basically evolve. So I do not have other slides in this presentation. I wanted to give a chance to the audience to ask me anything that they want related to cloud computing and artificial intelligence. I have worked in this domain for a long period of time, and about application of artificial intelligence to different verticals, or it's about cloud computing, industry dynamics, how things are evolving. Please go ahead and fire up questions to me. I'll might try my best to actually answer them and use some of the slides as a reference if some concepts have to be explained. Okay, so what I would do is I also want to have overall general conversation in terms of some of the players and the paradigm. So if you are trying to build a new solution, or you want to build a new business in cloud compute in artificial intelligence, the right way to do it is something. So if you want to build up a business in this area, want to leverage it, if you're a startup who wants to get into this area, here is how I would suggest you approach the whole problem. What you do is typically you basically create an account in Amazon Web Services, Google Cloud, or Microsoft Azure, whichever is your favorite cloud provider, or maybe multiple of them. And then you basically figure out what problem you are trying to solve. You will get your storage and compute from it, and then essentially leverage some of the existing tools which are already there to build your solutions on top of them. For example, if you want to basically develop a solution for figuring out who basically comes to your company in the morning and in the evening, you want to continuously monitor it, you can use Amazon Recognition for it, which is video and image analysis software. Or for example, if you already have a couple of models which data science teams are trying to build, and you're having tough time managing the whole model lifecycle, you can use Amazon SageMaker for end-to-end model lifecycle management. Similarly, for building recommendation systems, you can use Amazon Personalize, which is a way to basically work your way through that. There are different paradigms, different solutions, different way to look at it or work through it. This is something that I wanted to basically introduce you guys to and see which direction you want to take. We have a couple of minutes left. We started late, and that's how the direction in which the industry is going. Uh, Cloud computing has made it very easy, even for small startup, to start playing around with building solutions in artificial intelligence. And they do not really have to put a huge amount of capex investment. Just by creating an account and basically figuring out different models that you have, you can work your way through that. That's the way we look at it. That's the way you basically think through this. So if there are no other questions, let me give another minute or so to people to think through this and then see, or else we can wrap up the presentation. So if there's nothing else, I want to thank the audience for basically listening to us and looking at the slides. Uh, Feel free to reach out to me on LinkedIn. If you have attended this presentation, I'll be more than happy to accept your LinkedIn request. Avanti, any other topic you want me to cover, or any kind of issues or topics you want to address, let me know. I wanted to keep the presentation short so that we can give chance to the audience to ask questions. And thanks, Divya, for giving me the invitation to come over and present the whole paradigm of convergence of cloud computing and artificial intelligence together.
Thank you, sir. Sir, can you please post your email ID on the chat box such that delegates, if they have any queries, they can post it.
I can do better than that. What I'm going to do is I'm going to be putting my LinkedIn profile that people can reach out to me through LinkedIn. And let me put my LinkedIn profile here. And feel free to reach out to me through LinkedIn. Once you get connected to me through LinkedIn, you'll have my email address automatically. My email address is open to all that. Everybody's connected to me on LinkedIn, and I have a huge number of LinkedIn connections. So I wish the organizers the very best. I know you have the whole thanks, Bob. I see your message. So, you have a very packed agenda and a good lineup of speakers. So hopefully this presentation will give you an idea, the direction in which it's going. Yeah, there's one more topic I want to cover, and just talk through it for a minute. And that is this whole area of IoT, or industrial IoT that people talk about, and how does it fit in with cloud computing and artificial intelligence? Well, if you look at the whole paradigm, and when I was sharing my screen, uh, that I had my screen say ready when I was talking about, 1 second. Hopefully you guys can look at it. When we talk about things like IoT, right? It's not very different. It's not like IoT is a very new concept. What happens is when you're building these cloud computing models, IoT is a source of input. You can collect data from a lot of different sources and feed it to the model. And that's where IoT comes in play. The cloud computing plays a role because it provides an easy way to store and process the data that the IoT endpoints generate across the world or the overall system. So IoT becomes a source of input for data which is coming into a cloud computing artificial intelligence paradigm, and then you can basically process the output and we make your work way through that. That's what it is. That's how it works. I wanted to give you a context, how cloud computing, analytics, and IoT that people basically talk about fit in together. But thanks a lot. I think we are up almost at the time. So thanks and have a great day. And thanks to the organizers for inviting me. Thank you, Divya. Thank you, Avanti. Thank you.